example for you. The capabilities of Matlab are endless. Like suppose if you are working with some remote sensing tools, you are sensing some area, or you are working with GPS systems, or you're working with some mapping some area, you're creating some graphics on the world map actually for remote sensing or other purposes. Like if you are looking for the proper agricultural area, you want to mention that this is good for agriculture, this is good for mining, this is good for something else. So this is how you can test everything on Matlab. How? See, I have just prepared an example for you. Here is the insert mapping here. If you write world map, it's a predefined function here. World map of South Africa. You want a world map of South Africa, you just write like this, and you will like get a land area. Like shape reading is like very common while you're working with remote sensing tools. Even I was working with some agricultural authorities, and they were looking for a particular area. They want to do some research on it with the satellites. Um, so in that case, if you're mentioning your results, you need the maps, and Matlab is actually ready to help you out in every field these days. So shape read, land area of your geographical coordinates, like you're using longitudinal, latitudinal geographical coordinates are here, and it will show you this is South Africa on this much longitude and latitude, and the face color you have put it white here. You're mentioning like this is some particular area, this is its dimensions, you're positioning it, and very you're taking out some particular portion. Okay, you're going to work on this particular portion, and many calculations. This is like see, yes, they are segmenting some particular areas, they're concentrating, like this is the particular area. On Matlab, you can do wonders if you go in, if you take a deep dive in Matlab, it is itself a world. So I have just shown you this example so that you get some interest in 2D and 3D graphics also. So now, okay, I'm going to discuss one more new topic to you, that is subplots. You can write comment in live script like this also. You can take text also. It's up to you. This is my subplot topic. How you can get more than one axis on a single window. We have a subplot function. Suppose I have x is equals to 0 colon pi divided by 50. So we have already discussed all these things, so I'm not taking time on it. Y is equals to, let's say, sine of x, and then I'm using plot of x is here. So if you want to plot it, you need to run this file, and you get the answer here. Yes, this is my plot here. You can do many things on it, but right now what it is showing, only one plot, one axis in one figure window like this. But if I want to divide this figure window, this is my figure window, I want to divide this figure window in separate, like uh, sections. Like for that, I am using subplot for I want the area 2 cross 2, let's say 2 cross 2, and at the first position I want this plot. Which plot? X and Y. Okay, let me just check how it is. Changing. See, this is small, and if you write subplot with 2 comma 2, again the same shape of the matrix, and at the third position I want some other plot, like z is equals to cos of x. I'm writing over. I'm plotting y comma z. Okay, at the third position. Third position means somewhere there, because 1, 2, 3, and 4. I've divided my full screen into 4 parts. How 4 parts? 2 cross 2. This is the size of my subplot. 2 cross 2. At first position, I have mentioned this sign. Second position, third position, I have mentioned this circle here. Likewise, you can plot something else, like, but you need to mention the subplot. That is again the size of the matrix will be same, and at the fourth position, let's say I want some I have some equation and I want to plot that equation. How can I plot my equation on it? SYMS. Just wait, let me plot. I'll tell you what is SYMS and everything. Okay, and I'm using EZ plot. What is EZ plot? Wait, I'll tell you. 1 plus cos of. Okay, let me just go. Yes. Yes, it works. Very good. So what I have done is I've just booked the value position here. This is my fourth position in the 2 cross 2 matrix. This is my fourth position. SYMS of T. SYMS means symbols of T. I have an equation 1 plus cos T. Let's say I have equation and I want to plot it with using Matlab. It could be any equation like x, y, z, polynomial, any equation you can take. But T is unknown. This is a variable. T is unknown. So I have just mentioned that I don't know about T. What is T here? So make it a symbol. We have a different toolbox, that is symbolic toolbox, symbolic match toolbox, where all these kind of calculus, linear algebraic equations are being solved by Matlab very easily, and it is very fast toolbox. If you get a chance by any means, kindly to see this symbolic match toolbox. In that toolbox, we usually take sims of that variable, which is unknown. Because if I write 1 plus cos t and plot it, it will never plot it for you. It will ask you what is t. T is unknown. But if you make it as a symbol and use EZ, EZ means equation. They are saying equation plotting. Okay, and you just mention your equation like this. You will have the plot of that equation. Okay. All right. So one area has been left. Let me just make something interesting here. It's subplot 2 comma 2 and second position is left. Okay. Okay, so I am using SYMS again and telling the Matlab that in the coming equation, X and Y are the symbols because I don't know their values. I am using F mesh. Okay, F mesh is my predefined function. Let's say I am using sine of X plus cos of Y. This is my equation and I'm going to plot it. F mesh is a 3D predefined function, and Let me just check what is going to plot here. Okay, yes, this is my, you can rotate your 3D view. Yes, it is rotated. You can rotate your 3D view in any position. Like in 2D, you can see it like this. But if you working with 3D, you can see your data like this. Like this is 3D. This is how you can move your 3D data. That is because of F mesh. Mesh means grid, you could say. That grid, which is going to show you how your data is going to work with 3D. So this is the time to jump over 3D graphics, and this was just to giving you some idea about how my 3D animations or 3D data could work in Matlab. This is just for introduction. So I hope you get the idea of subplots here, and this is the time to jump over next window. Now we will start with working with 3D here. Let us just take one more example. If I write SYMS of X comma Y, not comma, consider. Okay, Sims means X and Y are the symbols. This is from Sims symbolic math library in Matlab. So I am taking F mesh again, same equation again, but little change I'll do. Wait, let me write plus cos of y. But here, what I am mentioning is I'm mentioning the limits of x-axis and y-axis. So minus pi to pi minus 5 say 5. Spacing is extra here. So let me get the figure. Okay, this is my figure, and the values are from, like, this is the button to rotate your 3D graphics. Rotate it for you. At the view angle, see, view angle will get changed over here. At what view angle you are comfortable, you are like having a good idea about your data. At that view angle, you can stop. Like whatever the view angle you want. Like this. Okay, let's just focus on this. Okay, this is my viewing area and I'm feeling comfortable. Fine. Flowers, everything is looking good here. Okay, so update the code. It is giving me update the code with this view angle. This is azimuthal angle and the angle of elevation. Both are here azimuthal and this will update, and whenever you run your code, it will get you this view angle only. So this is how you can create your equations in 3D views. I hope you get it. And okay, let us just do one more example. If I do text, come out. Text is, wait. Text is second example. Again, I'm on the code. This is the code. Works again. Let us just make a function, and we will call that function in fmesh. Then we'll create some good examples or simple, you could say simple examples. This is just for entering your equations, how you work with the mathematical equations, trigonometric equations. So this will be, must be the last SYMS example. F of x comma. Okay. So f of x comma y is equal to, let's say I'm taking the real values only, and tan value I am taking here for x plus I'm going to work on the real values only, but this equation is a little bit complex one. So x plus iy, complex equation in semicolon. Let me plot my f mesh. The equation could be like, you can take any equation. It doesn't matter. I'm taking this tan example here. Okay, let me run this. Firstly, this and then here. Yes, this is my second example. So this is how you can get your equations on Matlab, and you can start working with them and rotate them and see what is actually every like point in 3D also. You can analyze your data very easily in Matlab with every angle. In 2D it will look like this, and in 3D it is actually like this. Okay, if you want to update your data, like this viewing angle is okay for you, and you want to just update your data, it will give you a view angle over here, and always it will be at the same angle. All right, so I hope this equation plotting in 3D is fun for you. So let us just start some formal examples where we can do some learning how can we use to create some figures in 3D graphics. So first is, let us create your room. Okay, in room, in which room you are sitting, we can create that room in 3D. In Matlab, just count the windows, count the doors, exit or entry points in your doors, and just count the dimension of the room, and we will create your room in Matlab. So, okay, I'm going to create my room. You can create your own room in 3D. This is the first formal example of 3D graphics in yeah, for today. We have x is equals to 0:5. Let's say I'm using from 0 to 5. Y is equals to 0:5. Before starting the formal example, let me just take you with the new slide here. Okay, what we are going to make first? We are going to obviously make the floor. No, first, this is my floor. We're going to create the floor first. Let's say this is 0 point. This is 0 point. 0 y and 0 x. This is x-axis. This is y-axis. Okay, and from 0 to 5 I have taken for x, for 0 to 5 I have taken for y. Simple. But what I have taken from 0 to 5, 0:5 and 0:5 for 5, they are actually a row vector, 0, 1, 2, 3, 4 and 5. This is not actually going to give me any grid or something, because for flooring I want this kind of a structure. This is this kind of a structure.